revealed hundreds of billions of stars. Now search for them for life. For astrobiologists like me, the first image from NASA James Webb Space Telescope reveals infinite possibilities of life beyond Earth. This week, the James Webb Space Telescope made history, proving itself to be the most powerful space-based observatory humanity has ever built and revealing a tiny sliver of the vast universe around us in breathtaking detail. Astronomers the world over have been shown cheering in floods of tears and lost for words. Astrobiologists like myself, who study the origins, evolution, distribution, and future of life in the universe, are getting pretty excited too. By revealing images of galaxies from the dawn of life and chemical data of planetary atmospheres, the GWST has the power to help us answer our humanity's oldest questions. Are we alone in the universe? So as you can see here, this picture of the observations of the Southern Ring Nebula. The first spectacular image released was of the galaxy cluster SMACS 0723, known as Webb's first deep field. This image covers just a patch of sky approximately the size of a grain of sand held at arm's length by someone on the ground, and yet it is crowded with galaxies, literally thousands of them. Within each galaxy, there could be on average 100 billion stars, each with its own family of planets and moons orbiting them. Given the fact that in our solar system alone we have multiple habitable Earth or potentially habitable Mars, Europa, Enceladus, Titan worlds, then the odds of finding other planets or moons out there with the potential for hosting life as we know it have increased exponentially. The universe is probably littered with them. Using a different instrument called MIRI, Mid-Infrared Instrument, on the same view reveals even more about the character of these stars and galaxies. Some appear blue because of not having much dust and older stars, while others objects, probably galaxies, appear red because they are showered in dust. For me, the most exciting are the galaxies now colored green. The green indicates that the dust in these galaxies includes a mix of hydrocarbons and other chemical compounds, the chemical building blocks of life. The team has also released an infrared spectrum taken with a fine guidance sensor and near-infrared imager and slitless spectrograph (FGS) NIRISS instrument, which analyzed starlight as it passed through the atmosphere of WASP 96b, a hot, Jupiter-like planet 1,150 light-years away, orbiting closer to its star than Mercury does to our Sun. This bunch of wavy lines revealed us to the presence of water vapor in its atmosphere. The planet is way too hot for liquid water. This is a sensational result, and now the detective work really begins as we search the smaller, rocky planets in the hope of finding worlds where conditions are suitable for life. So how will we do this? We look for Earth-like atmospheres, once dominated by nitrogen, carbon dioxide, and water. As an Earth-like atmosphere is, by definition, our gold standard of habitability, but Earth's atmosphere over the history of life hasn't always been composed this way, and we're sure other atmospheric mixtures can create habitable worlds. We call these habitability makers, and they also include the glint of light reflecting off of oceans and the effects of vegetation. Astrobiologists are also looking to find biosignature gases in the distant explanatory atmospheres, that is, gases indicative of biological activity. For example, oxygen is a dominant gas in Earth's modern atmosphere, and most of it is produced from photosynthesis. Also, the dominant source of of methane in our atmosphere is produced via methanogenesis, photosynthesis, and methanogenesis as an ancient form of metabolism for some microorganisms. I should say here that identifying unambitious signatures of life isn't going to be easy. Many have abiotic, non-life sources as well as biological ones that can be produced by volcanoes, water rock interactions, or even human activity. At least for now, only those biosignatures with a global planetary impact will probably be detectable. However, the detection of these habitability makers or biosignature gases using the GWST will be enough of an enticement to make us pause and more deeply explore the words in questions, and that is more than exciting enough for now. The GWST has already, in just a few days, transformed the way we look at the universe and will be in the future open our eyes to the chemical land, if we are lucky, biological makeup of other worlds in it. Perhaps we will finally get the proof that life in one form or another is universal, and as I've always believed, that we have never actually been alone.